This little fella is my 1977-ish Bolens H16. It is in this building, so of course it doesn't run. But it is almost winter time, and I feel like I don't have to explain this part, so let's just get into it. A brief tour of the rig before we begin. This is a tube frame Bolens garden tractor, called so what for because why the tube is made of frames. The frame is made of tubes. The H in the model name tells us at the rear we have a hydrostatic transmission just like a modern riding mower. Unlike a modern riding mower, we also have a manual locking diff. Very fancy. The 16 tells us that it makes 16 horsepower on a good day. Also, with the power bulge on the hood, we can tell it is a performance model with the overhead valve Tecumseh engine. Big power. And this being towards the top of the line of the tube frame range, we have some nice bells and whistles like actual headlights, a hydraulic attachment lift, and a PTO. They all had those. Anyways, most impressively, you may notice it has 4 matching tires, all of which hold wind. Very impressive. But of course it still does have all the typical 50-year-old garden tractor ailments like very sloppy steering and a cobbled exhaust. Another unfortunate ailment, we can tell it is a later model, a 77 or 78, because of this very cheap and broken plastic instrument panel. As always, we will get to that, but first let us look in here and see why it won't go. Under here is an all cast iron Tecumseh HEI. These little nuggets have a habit of lasting forever, at least until the proprietary solid-state ignition system goes out. On this specific example, it seems that the proprietary solid-state ignition system has gone out. At least that's what the previous owner said, but you know how those are. Suppose we'll throw in an electron cube and check for a spark. Well, at least it has a new spark plug, because of course it does. No spark, very unsurprising. And there are other easy things I could check, but it's all getting replaced anyway, so we'll get straight to peeling it. This will get the usual treatment, so we'll just get it out of the way for now. Like most small engines, the thing that makes the spark is here by the flywheel, and controlling it is just a kill wire that grounds the spark when you want to shut it off. Unlike a magneto, however, there are no magnets in this flywheel. Instead, we have 2 little pins that register in a little Hall effect sensor right here. And then down behind the flywheel, built into the alternator, there is a separate charge coil that produces the energy for that spark. The advantage of this system is variable ignition timing. You'll notice there are 2 pins, one is taller. More on that later. That just lets us have a more retarded spark for starting, and then once it's running, that spark advances. Rather, you just get 2 sparks, one of which is more advanced. Doesn't matter. What does matter is that this little doohickey is proprietary to Tecumseh engines, and it's been discontinued for several decades now. Even better, everything in there is potted with an epoxy compound, so you gotta dig that out if you want to try to service anything in there. However, I would just rather make this go away altogether and use something cheap and plentiful. Luckily, I am in the US, and cheap and plentiful is the only thing American automakers ever got good at. And since I don't know that the charge coil in that alternator is any good, I'm just going to swap it out altogether for a battery ignition system. Specifically, a GIMME HEI battery ignition system. So breaker points are stupid, and this is what General Motors came up with in the mid-1970s to replace them. So instead of mechanical breaker points, this just uses a signal from a Hall effect sensor to charge and discharge the primary side of the ignition coil to make the spark. But that's not too important. All that's in here is a smart rock that turns a switch on and off when it's time for a spark. But what is important is how a Hall effect sensor works, so we'll talk about that. To put it briefly, electricity and magnetism are just 2 expressions of the same type of energy. So if you have current flowing through a conductor, there will be a magnetic field. And if you move a magnetic field across a conductor, there will be an electric current. So similar to how metals conduct electricity, ferrous metals at least also conduct magnetism, and a Hall effect sensor uses this principle to generate an electric current when a chunk of metal moves past it. In here we basically just have a coil of wire wound around behind a magnet, or in front of a magnet, doesn't matter. So when the tooth of the wheel moves past it, think the reluctor wheel in a distributor or the tone ring on an ABS sensor. When that moves past, it just stretches and squashes the magnetic field of that magnet just enough to induce a tiny little current in that coil. And that tiny little current is what the ignition module will use to fire the spark. Notice in the distributor we have the same number of teeth as we do cylinders. Of course, it's all different in an ABS sensor, but that's how the signal is generated. Onto the ignition coil, there are two coils in here, if you didn't know. The primary and the secondary winding. Just like a breaker point system, that primary coil will remain energized until it's time for a spark. And then the spark is generated by a sudden de-energization of the primary coil as controlled by the ignition module or breaker points or whatever. That then causes the magnetic field of the primary coil to collapse through the secondary coil, which is what induces the current to create the spark. The for because why of that, 12 volts won't spark across a spark plug. We'll need a couple thousand volts for that. So to boost that voltage, the secondary coil just has way more windings than the primary coil. That makes for more conductors being crossed by that collapsing magnetic field, which means more voltage. The trade-off is the current. We can't make free energy out of nothing. So while the voltage of that spark may be very high, the current is teeny tiny. And that's the same principle that a stun gun or a taser uses to generate an enormous voltage from a tiny little battery. But I don't think it's worth getting into Ohm's law and watts and whatnot for this explanation. You can Google those terms if you're curious. And I'm almost done talking, I promise, but one more thing. As mentioned, like most small engines, this doohickey just uses a kill wire that grounds the spark through the ignition switch when you want to shut it off. In order to use the HEI module and a regular ignition coil, we'll need a 12-volt supply from the ignition switch. This doesn't do that. So to make it work, I just have a generic ignition switch that will do that. Here's a diagram if you're really curious. I'm not going to spend too much time on where the wires go. And finally, we can actually begin by getting the old nugget out of the way. And here we see that potting that you have to heat up and dig out if you want to get in there. I have no plans on doing that, but given how much these things go for when they work, maybe I'll mess with it later, probably not. Now we have a better look at our flywheel pins, what will talk to our Hall effect sensor. As mentioned, there are two of them to create a retarded spark for starting. Without yapping about it for another 10 minutes, the difference in the height between them is what creates that retarded spark. If we were to look at the voltage output over time of this sensor as that pin goes past it, we would see a little sinusoidal-ish blip. Big word, don't be scared. Now I don't know exactly what the voltage is, but there's going to be a certain voltage in that spike that triggers the coil to send the spark. And as the engine speeds up and that pin is moving faster, that voltage spike will be higher. You'll notice that the first pin to encounter the sensor is shorter, and then the one at top dead center is taller. At lower RPMs, I think below 300-ish for cranking, only the voltage spike from that taller pin being closer to the sensor is going to be tall enough to trigger the coil. But once it's running, and up to a speed, I don't know, the voltage spike from this pin will also be able to trigger the coil. You may assume from that that you get 2 sparks while it's running normally, and you'd be correct. This is a wasted spark ignition system, although that second spark isn't the spark that's being wasted. Of course, it's a 4-stroke engine. It only makes fire every other rotation. But as you may have inferred from this explanation, this is still going to spark every time that crankshaft goes around. That just means that you also get a spark, in this case 2 sparks, at the top of the exhaust stroke. But it doesn't really matter. There's no simple way to make it not do that. Well, I said I wasn't going to yap for 10 minutes. Sorry, I guess. My point is, we need a sensor right here to talk to those pins. As I'm told, the GIMME HEI ignition module isn't very particular when it comes to a signal input, so apparently just about any Hall effect sensor will do. I have opted to use the rear ABS sensor for a 90s Ford pickup truck, for no reason in particular. So excuse me while I fabricable a bracket. And of course this engine is imperial, but I'm not doing that to myself. So here's a nice metric drawing if you need to make one. Those gussets probably weren't necessary, but I had the welder out. And now just for funsies, I'll hook this up to my tiny oscilloscope. There's that vaguely sinusoidal pulse I mentioned, a big spike for the tall pin, and a short spike for the little pin. Suppose now we'll wire up the ignition module and see if this will trigger it. And the sensor has to live under the shroud, so I'll begin by stretching the wires and giving it some conduit. Then I'll build out the rest of the circuit to run it straight off the battery, just as a proof of concept. Important note, this ignition control module grounds through its mounting screws, so I have added a ground wire and put it on its heatsink. And after adding the ignition coil from my Volvo 240, it doesn't need an ignition system where it's going, and a spark plug wire from an RX-7, that should be all set up. Do something. But just turning it like this, I do notice it's sparking on both pins, so I'll probably just need a bigger gap between the sensor and the flywheel. And with that, we have a working ignition system, just needs tidied up a bit. The only things left to sort out are the gap between the sensor and the flywheel, as well as the polarity of the sensor. I don't know at which peak from the sensor this thing's going to want to fire at, so I might have to switch those around. We'll just have to look at it with a timing light later. So to begin buttoning it up, we first need to make it actually work with the key, which means changing this ignition switch. And that ignition switch, of course, is mounted into this cheap plastic instrument panel. Now, I had actually prepared for this. Earlier tractors had a cast aluminum one. I was able to find one of those. Of course, it had some holes drilled in it, because they all do. But like a year ago, I cleaned that up, painted it, and put a nice new sticker on it, so that's ready to go in. Another thing they cheaped out on around the same time is the headlight switch, because there isn't one. It is integrated into the ignition switch. That's another reason I want to change it. I do want a separate switch. Again, with the yapping, let's just do work, I guess. And now that the battery even more doesn't fit, we can test our fuseless fire hazard. We'll get to that. And before I put the controls back together, I guess I'll make it go. First, I have to figure out the sensor gap. And now it's at about 4 millimeters. We'll see how that behaves. Next, to clean out the carb and redo the fuel system as per usual. And this is the third one of these tanks I have seen that's flat like this. To get my capacity back, I'll just do something inadvisable. Anyways, And just one more thing to verify before I go buttoning it up. I have added a ground wire for the voltage regulator down there. And if it charged before, it should still charge now. As per usual, I got a little carried away and ended up painting this cowl piece, replacing a bunch of hardware, and making some new battery cables out of this comically oversized 0 gauge. I just had some scraps left over from the GTI. I'm sure they're big enough. Also, it has fuses now, so it shouldn't catch fire immediately. Anyways, it's back together now, so it would be time to go for a drive. But before I started it again, I noticed the spark plug was kind of loose, although I had tightened it. Yeah, those threads are hashed. I had run a thread chaser through it earlier, but those threads are just completely mangled. So while I wait for a thread insert kit, suppose I'll finish peeling it and work on this very sloppy steering. So a brief assessment and no surprises if you've been here a while. This steering system is made of a column, a shaft with a bell crank on it at the bottom, and then a drag link that comes forward to the axle. Worth mentioning, all of that is cast iron, which is nice, but every single bushing and ball joint in the system is completely sacked out. And since the mount is already broken, I'm going to start by getting the muffler out of the way. And on every other tube frame Bolens I've worked on, this arm has been seized to this shaft. I really hope that isn't the case here, because that's really not fun. Well, it super is, so that's nice. And at the expense of replacing a metal stick, I'm gonna not take the steering column out this time. Now to address the floppy steering wheel, we'll have to at least take the shaft out. And since I don't want to pull the whole column, we'll have to pick it up quite far for that. Well, I guess I could pull it out the top, but there is a roll pin on that gear, and I really don't want to deal with that. Oh, the key is just as seized. Cool. And now I might have to make a new shaft for that, but I don't want to think about it yet. So the last thing to struggle taking apart this extra floppy travel pedal. And finally, the tie rod and the front knuckles. So naturally, this was a struggle. Until this point, I had yet to come across a tube frame Bolens where the front pivot pin wasn't completely dead seized into the axle. This became much easier once I realized it wasn't at all. But I will have to do some welding to make up for that percussive disassembly. I later realized the kingpin was stuck to the control horn because it was bent, not because of rust. Anyways, what was stuck because of rust was the keyway in the steering shaft. I was justifiably grumpy, so here's a montage I didn't feel like narrating. Now for the rest of the sticks that make up the steering, we still have to address the drag link, the tie rod, the travel pedal shaft, the axle pivot pin, and the steering shaft. First, the tie rod and drag link, they have these cheap little ball joints that are also completely wallered out. I will upgrade those to Heim joints, because more beef. The new Heim joint is a direct replacement on the tie rod that'll just thread on. On the drag link, however, the ball joint is made as one piece with the stick itself. To accommodate that, I will use a male threaded Heim joint, and to get a female thread on this end, I will just weld in a coupling nut. I don't feel like drilling and tapping a hole, that never goes well. Of course, you know I need to paint that. You've seen my videos. And that takes care of the back and forth ways sticks. Now for the rotational sticks. These are all 5/1/8 of 1 inch round bar, and they all have grooves worn into them where the bushings used to be. So to fix those, I just have some new 5/1/8 of 1 inch mild steel bar stock. Or not bar stock, rotary I don't know. Instead of vaguely round, it is actually exactly round. And with that, we're about ready to start putting things together, but a few things left to get ready on the tractor itself. First, the sloppy top on the steering column. A step bit is the wrong thing to use. And then some new bushings down below.
No.
The travel pedal shaft originally used split plastic bushings, and even if you could get those anymore, I'd still be putting bronze bushings in here. These are just some off-the-shelf flanged doohickeys. And now back to some sticks to start putting stuff together. Of course, the original ball joints had a stud. We now have no stud. So here is a socket head bolt, what not to impede the flex of that joint. And on the other end, I will use these locking jam nuts. That acorn shape on the end works just as well as whatever piece is actually supposed to go there. But since they are nylon lock nuts, I will have to unlock them with a tap first. And 8 of them, because as per tradition, I forgot to get regular jam nuts again. And don't act surprised, unless you're new here, in which case get used to it. I did find that brake clean just ate right through that old paint, so that was rather convenient. But that is going to make the rears look even worse. One moment, please. Okay, now I'm happy. As much of this tractor that isn't a dumb design, these roll pins very much are. Yeah, we're going with that. So now once again, this time with some nice tight steering, we would be ready to go for a ride again. So back to that spark plug hole. I tried one of those save a thread kits that lets you put an insert in there. It has a stepped tap to hog it out to an M16 thread, then you smack the insert in. But I learned very quickly that those are made for much softer aluminum heads. This being made in Wisconsin in the 1970s, it is aluminum. So before it even got halfway through, the tap started spinning and just hogged the hole out and made it a much bigger problem. And I don't yet have the equipment to weld and re-drill that hole, so I decided to look for another head. That's why it's now been 2 weeks since the last clip. But I have had time to do some other stuff, like the seat mount. The seats on these mount directly to the sheet metal fender, and they've been known to crack even with a skinny operator. I am not a skinny operator, so I reinforced the seat mount with some scrap angle iron. And that should be sturdy enough even for me. But after much digging and more waiting, I finally have another cylinder head for a Tecumseh HEI. I paid almost as much as I did for the whole tractor, but it's here. This unit even seems to be fairly low hours. Those valve seats are nice and crisp and the guides are nice and tight. But most importantly, the spark plug threads are intact. So now let's take apart all the stuff I just put together. And this is a bit of an annoying design. One of the head bolts is hidden under this rocker arm housing. So to get the head off, we actually have to drop the valves down into the cylinder. So first we'll put it at top dead TDC. Well, these are barely tight. That's oh, I immediately forgot that the valves were going to do that. That's probably fine for it. And this shrapnel is just from the spark plug debacle. By the end, I had already decided the head was coming off, so I didn't clean up very well. But we finally get to see what this cylinder wall looks like. And oh my, it is exceptionally nice. Well, hello. That might mean it's been bored over. Probably not going to measure to find out. And the new head came with its own valves. They definitely didn't need lapped. It won't surprise you that I did anyway. Just give the wall some oil before I close it up. And even with just one hole, there is a sequence and a pattern. Now that I'm following the pattern, I realize it's just a star pattern. And my universal O-ring kit had all the stuff I need for the rocker housing. Well, everything except for this special plastic O-ring on the exhaust valve guide. I don't know, I'll just put it back. And you may wonder why there's no valve stem seals. Most overhead valve engines, we'd have hollow push rods, and those would feed pressure oil up to the rocker arm. This engine uses a splash oil system, so there is no pressurized oil. Instead, they just put the crankcase breather at the top, so all of the crankcase fumes just blow up the push rod tubes and carry with them some oil vapor. And it just relies on that to keep everything up here wet. And right now I kind of wish I had made a spring compressor, but this oxygen sensor wrench is kind of working. I have made a valve spring compressor like I should have to begin with. Now, if you know what just happened, it was pretty stupid, but I recovered. And either the old valves were very worn or the head is just slightly different, but that's no good. What we want is 5 thousandths on the intake and 10 thousandths on the exhaust. Now once I put it back together, it should be running again, but it will take a break briefly and make a new exhaust. Now many of these smaller engines, especially in the 70s, use off-the-shelf black iron pipe hardware for the exhaust, which isn't very elegant, but it is cheap and easy to get. And this is the original pipe. For some reason it was installed like this instead of like this. One of the reasons the muffler looked all janky. Speaking of, this rig has the original Nelson shotgun muffler. That obviously needs to stay, but it needs some help. That will do just fine. Now to weld up this muffler mount. Looks like someone has tried to braze it in the past. Guess that didn't work. I sure do hope there's lead in it. And I'm not sure why these are slots instead of holes, but I have given it some probably unnecessary reinfortification. And I dare you to try and act surprised. This is silver now. And once again, don't act surprised. And we're finally back to where we were, so in a perfect world, it'll just start now. Don't want to be running it too long without the shroud, because that is the cooling system. Also, I'd like for it to be charging the battery. I have learned something against my will again. All of the screws that go into that front shroud need to be pretty short. The two on the bottom run into those firing pins on the flywheel, and the one on the voltage regulator runs into the cover for the Bendix drive. I learned that in the noisiest way possible. Of course I wasn't filming. What fun would that have been? But finally, it is time to actually drive the thing. I guess I'll put a fender on so I have somewhere to sit. I'm also going to put the hood on just to make myself feel better. And these have these dreadful little sheet metal clip nuts all over the place. I don't like them. I do like these clip-on barrel nuts. They don't fall apart. And yes, I have finally made it through a tractor project without deciding to paint it. This thing has a lovely patina on its own, but it's also going to match my HT20 very nicely. Now we need to make sure it comes nowhere near lining up with the instrument panel. Shims. And some chafing protection. Delightful. And of course there's still this hole from someone's makeshift hood latch. Of course I can't leave it like it is, but first. And then I have found a plastic trim clip and painted it. I will call that extremely adequate. And just so it can be visually complete, I have new LED headlights. I do like seeing. But actually, just kidding. I did try to go for a drive. Instead, I found a sunk float. So we'll return to this once it's put back together. In the meantime, I haven't even touched that thing yet, and that's like half the point of the video. Luckily for you, however, it's just a gearbox, 2 bearings, and a chain. So I think I'll shut up for a little while and just do a little montage. Now to interrupt my own program, because I feel like complaining, this all went pretty terribly, and just as expected, it took much longer than expected. The first headache of my own creation was the old paint that was on here, or those old paints that were on here. I wanted to take it to bare metal so this new paint would actually stay on there. The next issue that didn't really need addressed was the auger. There were some chunks missing. Probably would have worked fine, but I didn't like that. Next, the only thing I actually fixed was the bearings. When I measured them, they appeared to be a standard size, but then the new ones I bought didn't fit.
Nice.
So I did something a little misadvised. But that epoxy should only be under a compression load, which is what it's actually good at. Shouldn't fly apart, suppose we'll find out. And finally, if you look closely, you'll be able to detect that it is now yellow. That is the original color for some reason. Bolens did make a few yellow tractors, but none of the ones this thing would have gone on. Maybe for safety, but it was the 70s and safety hadn't been invented yet. I don't know, I made it yellow, I now like it. I did not like making it yellow. I've been using this exact flavor of paint for many years now, and never before have I seen it fisheye so badly. Fish eyes are this paint defect you get usually from surface contamination, but I prepped these exactly like I have everything else in the past 10 years. So on top of this auger now being my new least favorite shape to prep behind a coil spring, I had to do it twice. The second time using this white primer, I don't know, it seemed to work. It looks decent now. What doesn't look very decent is this. I did this first before I learned that. But just shooting the B-roll for this, it doesn't look like it picks it up very well on camera, so never mind, it is perfect. But I digest. At least its good side is the same as the tractor's good side. Also, it's still a tractor implement whose job is to get bashed against the ground repeatedly, so I'm gonna pretend I'm happy with it. Anyway, it's as ready as it's getting to go back together. I forgot the chain. I put the bar on upside down. Cool. Actually, no, I didn't. I got it right the first time. Unrelated, I'd love for someone to explain to me why sometimes a fastener will go together without issue, but then you go to take it apart and it decides that it's actually cross-threaded and breaks instead. And I feel like I've only ever experienced it with new Imperial hardware. I'm just going to conclude Inch is bad. But again, I got it right the first time and nothing happened. So moving on from nothing. Well, even with those paint defects, it's looking pretty snazzy. Let's put it on a tractor. Oh hey, the tractor is a tractor now. It also works. I tried for way too long to make that original carburetor work. I resoldered the float 4 times, made several bowl gaskets, tried a bunch of different needles and seats. There was even a helicoil involved. I don't want to talk about it. But it was just dumping gas both on the floor and into the engine. It got worse every time I put it together, so maybe there's a crack somewhere. I don't care. Now it has a carb from some newer Kohler V-twin, rather a Chinese clone of one of those. It was the only one I could find that had the choke and the throttle in the same location, where they also moved in the same directions. Luckily, an adapter kit is fairly easy. Of course I'm kidding, I had to make one. The bolt pattern was too close to make a simple adapter plate, but also too far to just slot the ears of the new carb. I did slot the ears anyway, but I had to come up with this goofy offset stud arrangement with a spacer plate to adapt the slightly smaller bore and make room for the throttle horn. The only permanent mod I had to make were 2 holes in the air cleaner plate, but whatever. It also has an electric fuel shutoff solenoid now because new stuff. That'll at least keep it from blowing fuel back through when you shut it off. Of course, it needs a switched 12-volt power source, which would have been an issue in stock form, but after the HEI conversion, I can just plug that straight into the coil. Anyways, it works now. It cold starts very nicely. I haven't even fiddled with the settings on this new carb yet. We'll see how it behaves under load. But speaking of tuning, as for the timing advance and the sensor gap, I don't really know. My timing light died. I ended up at about 7 millimeters. That's where it seems the happiest. I'm to assume the advance is working. I also played with the polarity of the sensor. Here's where I landed. That's just where it seems to run most best. And then finally, I also finished putting it together. Here's a little montage. Also, at some point I realized the camber on this side looked a bit wonky. I guess I had bent that spindle, massaging it out of the axle. But at long last, I finally have a tractor to mount behind the snowblower, and even a PTO shaft to plug it into. So let's do this part. Also, for some reason, this U-joint is specific to a tube frame Bolens, so at least I got to spend a bunch of money on that. Well, that's very nice to look at and all, but I still want it to work, and this hog remains very much uncranked. That being the chute rotation crank. I didn't have one to begin with. Guess I'll just make one. And ultimately, finally, for realsies this time, of course it started running like ass as soon as it got hot. I'll skip over this headache entirely, but I realized I had set the valve clearances to the hot specification when the engine was very much cold. In my defense, the Tecumseh manual doesn't separate those two numbers very clearly. What we actually wanted was 20 thousandths on the exhaust and 10 on the intake. And I did have to do some fiddling. I had to richen up that low-speed needle quite a bit, but now it runs just dandy. It did start doing this weird shuddering thing where the governor would try to overcompensate and it would flutter the throttle back and forth, then it would stall for some reason. I won't pretend to understand exactly why it worked, but I figured the throttle was just too floppy, so I added an extra return spring and now it's fixed. I spent a couple days just driving it around to make sure I was confident, saying it was finished. The only thing that really happened is it started cranking slow. Mercifully, however, you can still get a starter, not OEM of course. I did buy one preemptively because I figured I'd be cranking on it for a while doing that HEI swap. I also even remembered to do an oil change this time. Very responsible. As for testing out the snowblower, it is winter time, but now I have a working snowblower, so of course it's not going to snow anytime soon. But to have something to put in the video, I did find a pile of very soggy leaves. I also got the inevitable out of the way right off the bat. So yes, it is finished, it works, you saw that. But I am not happy leaving that timing situation a mystery. I did find my other timing gun, made some timing marks, and tried to evaluate it. I can see when the spark is sparking, but I have no idea if that's correct. There is no information, either online or in the original Tecumseh service manual, on how this system is supposed to behave. So the only thing I could really do, apart from the vibes-based tuning that I have already done, is compare it to another H16. But finding an original working OH160 with that Tecumseh SSI ignition system in 2025 is just about impossible, much less one I could fiddle with. You should recognize this. If you don't, you have a video to catch up on. This is my brother's rig I fixed up in this video. Since this has taken as long as it's taken, and this is still here, this has been pushing the snow around in the meantime. And this has all those things I just said were impossible to find. So some observations. The SSI system is dead steady with its ignition timing. I have looked at a few small engines with a timing gun, and this is by far the most stable. And it looks like I was correct. It should be running on the advanced spark at anything above cranking speed. Also noteworthy, looks like it's only making one spark when it's actually running. I don't know how it manages that, but I'm not changing all my animations now. With the HEI, on the other hand, oh. You know that feeling when you know better and you still make an absolute mess of things? As mentioned, electric current makes a magnet, and magnets make electric current. All conductors are essentially antennas, albeit not very good ones. I won't get into it too much, but what we're seeing here basically is just radio interference between two halves of the ignition system. As I always say, AC does weird shit, RF does crazy shit, RF being radio frequencies. But if you know Eli the Iceman, you've been introduced to all that. You're welcome for digging up that core memory. My point is, radiomagnetic interference can be quite the issue, especially with electrically noisy systems like an ignition system. All that was happening here is that high-energy spark from the coil was electromagnetically interfering with the sensor signal and making the timing jump all over the place. All I had to do here was reroute those sensor wires up around the other side of the engine to get it away from the alternator and the ignition coil. A nice easy job. Of course not. I found a bunch of magnet shrapnel in there. That was fun. Looks like two of the magnets had just fallen out of the alternator. Fairly common, easy to fix with some JB Weld. But also looks like the sensor had caught some of that shrapnel, so that definitely wasn't helping. And of course, I couldn't resist. For good measure, I also used a shielded twisted pair. That's just two wires with an extra metal screen around it that can absorb and then ground any spurious magnetic interference. The spark does move a little bit, but that's just inherent to how the hall sensor and the pickup work. I have no idea how this thing is so steady. Now, more sophisticated systems like in a car will adjust that timing based on load and RPM, but remember, this thing is rocking the same processing power as a pinecone. In a car that would have used that HEI module, the advance would have been managed mechanically in the distributor with flyweights and vacuum solenoids and whatnot. But yeah, I have no idea how it was running so well before. It runs even more better now. After a quick tune on the carb, it just works like normal. But with that, this thing's running about as nice as I think it can without going to an actual ECU and a proper trigger wheel. But if I'm doing that, I may as well do a whole EFI conversion. That is a project I've had in my head for quite a while. Maybe stick around if you want to see that. It's not going to be today. But if I want to eventually do that, I will first have to conclude this video. So now to do that, what I just said, in conclusion, I now have an H16 with a snowblower, and it works, and it kinda looks nice. Well, I do still have to change that hydro fluid, but this video's already pushing it. Another thing I didn't do were the stickers. I did buy a new set a little while ago, but these ones aren't that terrible. Now, the thing that bothers me with the new stickers, if you know me, and if you know, you know, that I'm a bit particular about my fonts, and the font on the new stickers is just wrong. And I think that would bother me more than how they look now. I will just tell myself they match the patina and be happy. But on to the real reason I bring up stickers. Okay, now it's done. These are a parody of the earlier tube frame hood stickers, And instead of FMC Corporation, it is JMC Contraption. Those are my initials because I'm creative and hilarious. Also this, I learned vector drawing for this. Buying such a shirt will increase the reliability of your small engine's ignition system by 67%. Results may vary, void where prohibited. There's also an updated version of the blue shirt with the logo if you'd like to cure your stage fright instead of beefing up your Bolens ignition system. These are the same very comfy, rather heavy-ish t-shirt as last time, but instead they are done with heat transfers instead of the screen printing. I think that just captures the detail in these drawings a little better. They look a bit crisper. So that link is where you'd expect it to be. Buy them now. I could only afford so many. So ultimately and anyways and finally, if you really like my face and my voice, you can support me on Patreon and maybe see some random sporadic behind the beans content. Thank you to my current Patreon members. I love you. Anyways, I am Chinchilla and this has been Baked Beans Garage. I will see you next time.